Assalamu alaikum. Today I'm going to talk about math behind RSA encryption. All of us know how it's important, or how much is important to keep our data in safe. The most efficient way to do that is by using RSA public encryption. I will try in this short talk to describe the math behind one of the most important public key crypto systems, which is the RSA encryption. In 1978, Reist, Shamir, and Edelman introduced a cryptographic algorithm. The most important thing in that algorithm is something called the trapdoor function. What I mean by trapdoor function is it a function that is easy to compute in one direction, but it's very difficult to compute in the opposite direction without using special key. A real life example for that, let me consider that padlock. This padlock with its private key is easy to close. Opening it is a very difficult process without using the private key or its unique key. So, the three scientists used the fact that product any two numbers is an easy process. But if you have a huge number, it is not easy process to compute the factor of that huge number, especially if those factors are prime numbers. Okay, let us see the beauty of this outstanding idea. I will start talking about this picture, which is summarized how we can exchange our data in safe. Suppose that this is the user want to use, for example, the website of our university, the KFUPM whatever. Now, if the user starts using that server, then the server will send him something called public key. The user will use that public key to encrypt his message, and the encrypted message will go through internet, so anyone can have that encrypted message. But the only one who can decrypt that message is the one who have the private key. As an example, let us suppose that Sami will need to send me a message M without anybody know about that M other than me. Okay, I will send to Sami public key, which is E and N. Sami will decrypt his message to C, and C will be also available for anyone. So all the users have E, N, the public key, and the decryption message, C. The only one who can decrypt that message is me, because I am having the private key. So the trapdoor function is that function, because it's easy to compute. If you have your message and EN, it's easy to compute C. But it is very difficult to find its converse without having D, which is the private key. As an example, so I will illustrate how the algorithm starts. The algorithm started by choosing two prime numbers, and for simplicity I will choose P and Q to be small prime numbers, 3 and 11. N is their multiplication, which is 33 in my case. Then I will evaluate the Euler phi function, which is in our case will be B minus 1 times Q minus 1. In our case, phi of n will be 20, because 2 multiply 10 will be 20. Now, E will be any number between 1 and 5n such that it's relatively prime with phi n. So I choose it to be 7. Now, again, Sami want to send me the message 2. But he cannot send me that message directly, because he have to encrypt that message. So I will send him the public key, which is E and N. And using that equation, he will encrypt his message using that equation to be 29. Okay? Now, we can evaluate D using that equation. We can evaluate D using that equation and decrypt the message by the converse of that equation to get 2 again. That's all. Thank you. He's my close friend. Now, okay. My name is Shadi Al-Omari. I'm from Jordan. I'm working here. This is my 4th year working in applied mathematics with Dr. Zaman. Why I choose my topic, which is RSA encoding, because it's very important how to know how we can exchange our data in safe. So anything you want to know?
Yeah.
I didn't know.
RSA topic was very attractive. It's very close to KSA, Kingdom Security.
Okay, any question? Okay. Yes.